One of the top Fortune 500 companies actually set aside a time for the week to innovate. They take these highly skilled professionals that works in the IT department, and they say, you know what, I want you to spend this time to sit down and think about innovative solutions. Innovation is one of the competitive strategies now, especially by companies who want to take their company into the future. Our next presenter, Samantha Deoraj, hails from university, very young graduate. She's a graduate of the Faculty of Engineering from UWI, local content. Samantha majored in the energy stream with a keen interest in renewable energy, as well as applying engineering methods to sustain the environment. She is currently a graduate mechanical engineer at NGC. An evaporative cooler was designed, built, and tested in order to maximize the shelf life of the produce, thus reducing the losses endured by small-scale retailers. To tell you more about this, I present to you Samantha Deoraj.
Hi, good afternoon, everyone. President Apet, Chair IMECI, IChemE members of the APET. My name is Samantha Deoraj, and today I will be presenting local innovation, which is an evaporative cooler for the storage of fresh fruits and vegetables. Evaporative cooling. Many of us have experienced evaporative cooling. I mean, when we're at the gym and we get that cool sensation after working out, that is evaporative cooling. It's a physical phenomenon which involves the evaporation of a liquid, typically into surrounding air, into an object or liquid in contact with it. Traditionally, it has been used as an economic and efficient method in the reduction of temperature and increase in the relative humidity in an enclosed area. Currently, there's a problem at large here, right here in Trinidad and Tobago. Research has shown that in developed countries, 5% to 20% of post-harvest produce are wasted, whereas in developing countries such as Trinidad and Tobago, that percent has increased to 25 to 50%. So small-scale farmers and retailers are suffering severely due to these losses. So why not have a device which can maximize the shelf life of a produce that traditional storage methods such as compressor-based technology can offer? Such a device is an evaporative cooler. Why should you consider evaporative cooling over compressor-based technology? Well, it is inexpensive, energy efficient, and environmentally benign. Let's look at the objectives in order to accomplish such an invention. Firstly, you'll need to analyze strengths and weaknesses, and this is what we did of previous evaporative coolers which were invented, as well as looking at patents and stuff. This ranged from not only evaporative cooling for food, but traditional household evaporative coolers. These were benchmarked in order to design this evaporative cooler, as well as to generate the most operating cooling conditions. So in order, right here in Trinidad and Tobago, we have a wide base materials which could be used for an evaporative pad. So 3 evaporative materials will be utilized in this experiment, as well as 3 different airflow rates which could be used in order to generate less energy, in order to produce a cooling effect, as well as actually test the system using actual fruits from harvest, as in order to replicate what these farmers would have to endure when they harvest their produce. In order to design such an evaporative cooler, various requirements were explored. Such requirements are to have a device which is cost-effective with respect to the cost of maintenance and operation, to have a device which is portable so farmers or vendors can take it to site, whether that be the market or their farm or wherever they may be, to have a system which can store a considerable number of produce at once, to have a system which can actually maximize the shelf life of the produce, to have a device which local farmers can operate easily, as well as the device must be durable and replacement parts for such a device can be easily sourced. In order to design this device, various concepts were generated. 3 concepts were explored. First concept involves direct evaporative cooling. This is where we have an extraction fan, a cooling chamber, evaporative pads on either side. What would happen is that there's a sump tank at the bottom here. Water will be dispersed over the pad. When the pad is moistened, the extraction fan will produce a cooling effect. Calculations for this was based on the CFM of the box, but this method was not considered. Another method was actually designing the pad in such a way that it was cylindrical in order to attain 100% efficiency of saturation effectiveness. When the cooling chamber here produced that cooling effect, it will then send the cool air to produce, which will be stored in a separate chamber. Third concept was using a heat exchanger in the process to actually produce a more cooling sensation. The heat exchanger was a plate and fin heat exchanger, which would be stored at the outside of the cooling chamber. Cool air would be generated in the cooling chamber and sent to the storage chamber. An extraction fan at the top here will create that draft, which would pull the air over the produce, so you would have dry air occurring within that box. So in order to evaluate the concepts, a scoring matrix was utilized. It ranged the concepts on a 1 to 5 scale, and overall, the third concept, which was the heat exchange, was applied with a few modifications. Such a modification was using a shroud in order to maintain that cooling when produced from the heat exchanger and sent to the storage chamber. After the device was constructed, various tests were implemented in order to determine the efficiency of the device. Such a test was a factorial experiment in order to determine the effect of 3 different materials. The 3 different materials which were used were cedar, teak, and coconut fiber. The shavings were locally sourced from sawmills, coconut fiber from the backyard of somebody's house. And these materials were used because of the water content, the bulk density. It possessed tolerable rotting resistance. So if you have a pad created from this material, the maximum time it can last for, being wet every day for 5 months, is 5 months. 3 different speeds for the extraction fan. These were 4 meters per second, 6 meters per second, and 8 meters per second, based on the CFM of the cooling chamber. The time of the day, so you wanted to see how the cooling was affected based on the morning or evening period, as well as how long the period of operation was. This was done in terms of minutes. After the optimal conditions were designed from test 1, test 2 was conducted. Test 2 involved using actual fruits for the experiment. So 110 Diane tomatoes were harvested from a local vendor in the Orange Grove Estate, agricultural estate. And using these tomatoes, a destructive test was conducted. So what we did was, over a 14-day period, we had 3 conditions, that being the evaporative cooler, a refrigerator, and ambient conditions. Each day, for over 14 days, 3 tomatoes were removed from each condition and tested various parameters in order to determine which condition provided the optimal cooling condition in terms of various physiological tests. Such tests were measuring the penetrometer depth. So this was a penetrometer which was used. These are actual pictures from the experiment. And you'd have your sample and you'd test the penetration on the opposite side of the stem as well as the middle of the tomato to decide what was the firmness. This was measured in millimeters. This was done for 14 days. It was compared in the evaporative cooler, the refrigerator, and ambient conditions. Your pH content, the more acidic the tomato was, the better it was for eating purposes. And measuring the sucrose content using a total solubility solid. So a refractometer was used in order to determine this over the 14-day period. Based on the results, what we found was that the saturation effectiveness was highest for the cedar shavings, and as it produced a larger temperature difference as compared to that of teak and coconut fiber. as well as the speed of the extraction fan was 8 meters per second, you got a higher saturation effectiveness and temperature difference at this speed. And analyzing the results from test 1, you would see that for the morning and evening period, for the cedar and the teak shavings, there was an interaction. However, upon replication, for the coconut fiber, there was no interaction occurring. Same thing can be said for the temperature difference in terms of the morning and evening period. Again, for the cedar and teak, there was interaction. However, for the coconut fiber, no interaction was noted. Based on the analysis from test 2, what we found was from the 3 parameters which were explored based on the method of storage, the pH content was actually the best using the evaporative cooler. However, in terms of the firmness of the produce, the penetrometer readings were the best for the refrigerator, followed by the evaporative cooler. Ambient conditions produced the worst penetrometer readings. The total solubility content was the best for the evaporative cooler. Reason being that the evaporative cooler, whereas in your refrigerator, you find that when you have your produce there, you find condensation occurring on it, which would actually increase your ethylene production. So what the evaporator had was dry air occurring, so there was no condensation occurring on your produce. Interaction graph would show the different penetrometer readings and based on the number of days. So for each day, the reading was noted in millimeters, and as you could clearly see, by the 14th day, the samples for the tomatoes were the worst using the ambient conditions. We have the visual representation of the actual produce after 7 days of storage. What you found that the ambient condition, the tomatoes stored there, were at stage 6, being the last stage in the development cycle of the tomato, which was at ruby red in color, compared to that of the refrigerator and the evaporative cooler. They were more orange red in color. After 14 days, some of the tomatoes in the refrigerator was still at development stage 5, whereas ambient conditions 100% stage 6, evaporative cooler about 90% in terms of the color in stage 5, stage 6. So the social, environmental, and economic benefits of the evaporative cooler. The results shown in the experiment can not only be used for actual evaporative coolers, but it can also be used in poultry depots, warehouses, aquaculture production, as well as assisting small-scale farmers and vendors in their transporting their produce from one area to the next, because the results showed that for the post-harvesting, the tomatoes can actually be stored in an upright position rather than being laid down, because that's where it's greatly affected in terms of its firmness. In conclusion, the evaporative cooler was designed, built, and tested, and it was in a safe method. The cedar shavings had the highest saturation efficiency as well as temperature difference, and using the Minitab software, the best method for storage of the fruits was in terms of skin firmness was the refrigerator, but for pH content and your sucrose content, the evaporative cooler was effective. Various recommendations can be further explored. Such recommendations can be added an air purifier system to the inlet of the heat exchanger. That's to filter out any microbacterial organisms. Instead of using a drip system, which moistens the pad, you could use a mist system to achieve like 100% moistening of the pad. You could have a control system to regulate the level in the sump tank instead of manually topping up the water, as well as use visual image processing system to determine the pixel color index of the produce compared to the results attained. This brings me to the end of my presentation. Thank you for your time. We'll now have questions and answers.
Thank you, Engineer Samantha. And if I could just ask her to hold on for a couple of minutes, we will entertain a few questions. Roger.
Ian Telfer, CMAS. I noticed that you chose cedar, teak, and coconut husk, but was any consideration given to the use of boxwood, which is a lot cheaper than cedar and tends to absorb a lot more moisture?
Okay. So when from the data explored the cedar and the teak, based on the microstructure of these particles, it was suggested by Professor that we went ahead and used these materials as previous research was done on it. So that's why we used the cedar and the teak as well as the coconut fiber because of the absorptivity level in it.
Winston Mellows, you talk about sustainability. Just a couple of quick questions. What is your source of electricity?
Currently, it's being used, since the extraction plants are DC, you could use, for farmers, if they need to transport it to a farm or to the market, they could use a battery source. But currently, right now, the prototype uses actual power from...
So are you considering any other sustainable source of electricity?
Well, solar energy can be a possibility, it can be used, but that would be further research.
You can consider solar. How portable is this device?
Currently, it is not portable, but the idea is that you can have a blueprint and the idea can be sold to local farmers or vendors to be used.
And finally, what sort of produce can you derive? And you mentioned that in the morning is not as good as the evening. Is this going to run all through the day, or do you have to take the produce out? The
testing was done based on morning and evening period. Over the 14-day period, the cedar pod was used, and what you found that the temperature was actually stabilized. There was no interaction for the coconut fiber, but for teak and cedar, you found that you did actually attain the temperature difference as well as the relative humidity that you were looking for. In terms of portability, it can be dismantled because there's three components, which is the cooling chamber, the heat exchanger, and the storage chamber. It can be dismantled. However, at the current prototype, it's not as easily portable right now.
Fazil?
Samantha, that was quite excellent. It's very impressive. I want to use you to do my presentations next time.
No problem.
I'm very skillful with PowerPoint. Question is, who owns this? Is it the university or yourself? And is there some mechanism for doing what the next step is, which is to get it out there and get real equipment built and utilized?
Currently, the prototype is located at the Energy Lab at the UWI. So it's the property of the UWI, but I was granted permission by Professor Ekwue to use it as my own for the time. So any further development would be through UWI.
Samantha, my name is Jeffrey Chen. I'm from Massey Energy.
Hi,
I just have a quick suggestion for you for further investigative work, and that is because evaporative coolers basically work on relative humidity differential between the saturated pad and the ambient relative humidity. Maybe you should consider some long-term testing over the dry season and the rainy season to see if there's any difference in the effectiveness of the cooler.
Okay, thank you very much for that. Well, when we did testing, this was actually my final year project. So it was the construction and the testing was done from September to March. So construction was done like from January to February and then a month full of testing. But thank you for your recommendation.
Any other questions from the floor? Okay. So this project potentially could be looking for some investors. Anyone interested? I would like to suggest that both Samantha and Michelle catch up. This could be one of a sustainable initiative in the agricultural sector. And I would like to thank Samantha. This has been an excellent presentation. Let's hear it.